Honors Algebra 2 Pre-Calculus. We're doing 10.7 in Pre-Calc, which is polar coordinates. So you currently know / use what we call rectangular coordinates, x, comma, y. You'll also hear these called Cartesian coordinates after Descartes. Essentially, x comma y means x is the horizontal directed distance from the origin, y is the vertical directed distance from the origin. For example, the point 3 comma 4 means that it is 3 units to the right of the origin and 4 units up from the origin, right? So here's my point 3 comma 4. So that's one way to measure position, right? We call it rectangular because essentially you're looking at a rectangular grid. That's not the only way to measure position, right? So let's say that you were talking about position as in a location in a city in a city with blocks, right? Then rectangular coordinates would make a lot of sense, right? Because you have left-right motion, right, on the streets and up-down motion. So you could be 3 blocks to the right of where you started and 4 blocks up from where you started, but that would make sense to use a rectangular grid. It doesn't always make sense to use a rectangular grid. So if you picture instead what it's like to be, let's say, a ship out in the ocean or a plane flying in the air, when you're a plane flying in the air, it doesn't matter if something is 3 blocks to your right and 4 blocks up because there aren't blocks. The same thing if you're a boat in the ocean. That's not how it works, right? What matters to you if you're a boat in the ocean, right? If you're a boat located right here in the ocean, you care how far things are from you directly, right? Because there are no blocks. This is as the crow flies or as the boat sails or as the fish swims, right? So in situations like that, we have a different way to measure our location. So one way to measure location is rectangular coordinates, which tell you how far right or left and how far up and down you are from a particular location. Another way to plot coordinates is what's called polar coordinates, and that's what we're going to talk about today. So I want to give you this so that you understand that you already use a coordinate system and you're just learning a different coordinate system. You can describe the same point in both ways. I could describe this 3 comma 4 either as 3 units over and 4 units up, or there is a way to describe exactly how far this is and in what direction from this ship. Okay, so let's walk through polar coordinates. So polar coordinates, instead of using a horizontal and a vertical distance, polar coordinates use r comma theta. Okay, so polar coordinates are r comma theta. Now let's talk about what r is. R is a directed distance, not horizontal or vertical, just directed distance from the pole, which is still, so that's at the same spot as the origin, okay? Right, so we just call it the pole. So it's the same spot as the origin. And theta is an angle from the polar axis. Which is essentially aligns with what we call the positive x-axis, okay? So the polar axis. So, essentially what I mean by r being a directed distance is that if r is positive, you walk in the theta direction, and if r is negative, you walk in the opposite of the theta direction. So let me show you an example of what that looks like, okay? So the polar coordinates, let's do 5 comma pi over 6. Here's, oh, I don't want 5. That's going to be awful. I'm going to regret that. Let's pick 2. 2 comma pi over 6. Okay, so here's what the polar coordinate 2 comma pi over 6 looks like. Polar graph paper doesn't have rectangular grids. Polar graph paper has concentric circles. The reason for that is that you're not measuring horizontal and vertical distance, you're measuring directly from the pole in the direction of theta. So it's got these like concentric circles. I don't have any polar graph paper with me right now, so I'm going to do a terrible job of showing you what it looks like. But you can also, if you don't want to have to do this on something like a homework, you could just Google polar graph paper PDF and download one. Okay, so here's the idea. Most polar graph paper has all of your typical angles that you'd see on the unit circle. They're going to have the pi over 4s, right? They're going to have pi over 6. They're going to have a pi over 3, right? And this is not drawn as well as it would be if I weren't me or if I had printed this. So again, pi over 4 goes straight up the middle. Pi over 4 goes straight up the middle. Pi over 4 goes straight up the middle. Pi over 6, pi over 3, pi over 6, pi over 3, pi over 6, and a pi over 3. Okay, so again, these are all the typical angles you'd see in the unit circle. I'm only going to label the ones in quadrant 1 for right now because that's all I need to make my point. So if I wanted to talk about this point in polar coordinates, it would mean face this direction. So I start at the pole, which is the same spot as the origin. I face pi over 6, and then I walk 2 units in that direction. So this spot right here on the second of those rings, that is the spot 2 comma pi over 6, right? If in red, I had done, let's say, the point, so let's also do, just as a visual, let's do -3 comma pi over 4. Well, -3 pi over 4, I face in the pi over 4 direction, right, which is this guy right here, but then I walk backwards 3 units. So from the pole, I'd walk back 1, 2, 3 units onto essentially my 5 pi over 4 angle, right? So it's interesting to note that -3 comma pi over 4 is actually the same as facing 5 pi over 4 and walking 3 units in the positive direction. So they would actually both give me this same point. So I don't actually, it's not the line, it's just this floating point. I only showed you the line so you could see what I was doing. So I walked 1, 2, 3 backwards from pi over 4, but they're actually the same point. So again, you start at the pole, you turn to the direction first, and then you walk however far the radius is. That's how polar coordinates work. So we're going to spend this chapter talking about how you convert between polar and rectangular coordinates, talking about how you graph polar coordinates and all that good stuff, which is basically just what we did here, but we'll do a lot more examples.